Welcome back to Summarize Science. Humanoid robots are becoming incredibly advanced, but they have a big, expensive weakness. They can fall. And when a complex machine like this takes a tumble, the repair bill can be enormous. Researchers at the University of Michigan wanted to solve this by giving robots a single, unified instinct for self-preservation. Their goal was to create a policy that helps a robot prevent falls when possible, fall safely when it's unavoidable, and get back up on its own. As you can see here, their robot demonstrates this entire process smoothly. Before this, approaches to robot safety were fragmented. You might have one program just for balancing and a completely different one for standing up after a fall. This paper introduces a system called FIRM, which stands for Fall Mitigation and Recovery from a Few Human Demonstrations. It combines everything, balancing, falling, and recovering, into one seamless behavior. So how did they do it? Their four-step process is brilliantly laid out in this diagram. First, they collected data by recording a few humans falling and getting back up, providing a blueprint for safe movements. Next, they used this human data as a starting point for an AI to practice and explore, generating thousands of additional safe ways to fall and recover tailored to the robot's own body. All of these learned behaviors were then distilled into a rich, multimodal memory, like a library of safe reactions. Finally, an online adapter acts as a real-time decision-maker, instantly picking the best reaction from that memory based on what's happening to the robot at that very moment. The results in simulation were impressive. On challenging terrains like uneven ground, their firm policy had a success rate over 93%, while a leading competitor struggled at just 23%. These graphs also show that their method significantly reduces the peak forces and acceleration during impact. In simple terms, this means the robot experiences a much softer landing, drastically reducing the risk of damage. But does it work in the real world? Absolutely. On a slippery surface, their robot successfully recovered 8 out of 10 times, where other advanced methods failed almost every single time. This image also shows how the robot intelligently adapts its movements when carrying a heavy and unstable payload, using its arms differently to push itself up. The system is also smart enough to prevent falls altogether. Here, the researchers simulated a sudden power outage, and the robot instantly reacted to rebalance itself instead of collapsing. And this side-by-side comparison really tells the story. The competing method's recovery is awkward and unstable, while the firm robot gets up with a smooth, natural, and stable motion. So let's recap the key takeaways. This research introduces a unified policy that gives a humanoid robot a complete survival instinct, learned from just a handful of human demonstrations. This allows the robot to avoid falls, fall with minimal impact, and recover quickly and reliably across diverse conditions. This is a massive step towards making humanoids safer, more resilient, and more practical for operating in our unpredictable world. It brings us closer to a future where robots can work in dangerous environments or assist in our homes without the constant risk of a costly failure. Thanks for watching Summarize Science.